Let's get started on Chapter 13, Troubleshooting and Support. In this chapter, we will look at documentation, the troubleshooting method, web resources, troubleshooting tools, and disaster recovery. Let's discuss documentation. There are two parts of documentation, what you got and what you did. Let's look at the what you got first part. Whenever we get a new computer here at the Community College of Baltimore County, we enter it in inventory. We enter the type of computer, the amount of RAM, the type of processor, the size of the hard disk, the type of the network interface card, the operating system version, and any applications which are installed. We have 5,000 computers here at CCBC, and in our inventory, we know exactly how much RAM is in each computer. Another part of documentation is the cabling map, and the cabling map can be very useful in troubleshooting. If we look at our networking diagram right here, and if I tell you that workstations 1, 2, and 3 cannot get to server 1, but workstations 4 and 5 can get to server 1. If you were to look at the network diagram, you could see that workstations 1, 2, and 3 all share the same common router. So this implies that router 192.168.2.2 is the reason that workstations 1, 2, and 3 cannot get to server 1. Network diagram, very useful for troubleshooting. Another part of documentation is the what you did part. Every time a technician at CCBC goes to fix a PC, he goes to the repair log and enters which computer it was on, what was the problem with the computer, and what was the solution. So that way, if a week later another technician goes to the same computer, the technician can look at the repair log and look at the history of that computer. Documentation includes what you got and what you did. Let's discuss the troubleshooting method on page 571. The troubleshooting method, whether you are troubleshooting a computer or troubleshooting a car that won't start, is the same. The troubleshooting method employs a systematic process of elimination whereby we identify the system, identify all related components, and test each individual component. So here's the example. The user Bob says he can't access the internet. Well, we have to identify what are all the components. We've got the router, we've got the cabling system, we have Bob's workstation. Now, first we determine to see if somebody else can hit the internet. If other people can get to the internet, but Bob cannot get to the internet, well, then the problem is not the router or not the internet connection. Most likely it's a cabling problem or a problem with Bob's workstation. So we verify that the cable is plugged into the back of his computer. We verify that he has a good network interface card, that the network drivers are loaded, network interface card drivers are loaded, and that TCP/IP is properly configured. Now, if Bob cannot get to the internet and nobody else can get to the internet, then that implies that there's something wrong with the connection to the internet. So then I would go to the router. I would make sure it's plugged in, I would make sure it's turned on, and I would make sure it is properly configured. If I think it's a bad network interface card in Bob's workstation, one of the simplest ways to determine whether or not a component is bad is to swap it out with another identical component. And this is called the replacement method, page 574. If you think the network interface card is bad, but you're not sure, you swap it out with a network interface card which you know is good. And if that solves the problem, well, then you know it was a bad network interface card. If you think the switch is bad, but you're not too sure, you can swap it out with a switch which you know is good, and then you will know that the switch is the cause of the problem. If you think it's a bad component, you just swap it out with another good component. I had a medical doctor in one of my classes, and he said, well, you can do that. You can just swap out parts. He said, in my business, if you think somebody has a bad kidney, you just can't swap out the kidney. You've got to be really sure before you cut out that kidney. So a nice thing about the computer is that we can swap components to determine whether or not those components are bad. Page 586 discusses the World Wide Web. We can use the web to download drivers and to retrieve how-to information. For example, if we need a network interface card driver, we would go to the Hewlett-Packard Compaq website, because here at CCBC we use a lot of HP Compaq. And then we would select download the drivers, and then we would download the driver for the network interface card. We could either select Run to install the network interface card driver on this computer, or we could select Save to save the driver to a USB drive, and then we could take it to the computer which needed the network interface card driver. The World Wide Web can be used to download drivers. The World Wide Web can also be used to learn more about particular technologies. Suppose we are trying to decide whether or not to implement a DHCP server. If we go to Microsoft's TechNet, we can see how DHCP works, and then we can decide whether or not it's for us. Or here's another example. Suppose we are installing a Windows 2008 or 2012 server, and we are trying to determine whether or not we want to use Server Core. Server Core is an addition of Windows Server that has no graphical user interface. It has command line only. And TechNet will describe the uses of Server Core, and then you can decide whether or not it would be appropriate for your organization. Troubleshooting Tools, page 589. Ping is a troubleshooting tool, and you might not think of it as a tool, but it is. It's a software tool. Page 591 discusses how we can use ping in troubleshooting. Now, you know what ping is for. Ping is where one computer sends a signal out to another computer. And if the other computer responds, then we know that the other computer is up and running, and all of the cables between us and the other computer are good. So let's look at troubleshooting using ping. You can troubleshoot using ping using a systematic process of elimination. Here's the situation. The user says he cannot log in to server 1. So we have to figure out, is the problem the workstation, is the problem the router, or is the problem server 1? So what we will do is we will use the ping command. We will go to that user's workstation, and to determine if there's a problem with the workstation, we go to the workstation and we try to ping ourselves. Now, to ping yourself, you can type the IP address of the workstation where you are, such as 10.0.0.4, or you can use the self-test. If you ping 127.0.0.1, that means you are pinging yourself. If you cannot ping yourself, well, then the problem is your workstation. Either TCP/IP is not properly loaded, or you've got a bad network interface card driver. If you can ping yourself, well, then at least you know the TCP/IP is properly loaded on your computer. Then the next thing to do is to ping your nearest neighbor. If you cannot ping your nearest neighbor, well, that implies there is a cable break somewhere between you and your neighbor. If you can ping your neighbor, then you know that your cabling connection is good. The next thing is the router. You try to ping the near side of the router. Now, as you know, a router has 2 or more network interface cards in it. So if I try to ping the near side of the router and I cannot ping the router, that implies that either the router is not up and running or the cable is just not plugged into the router. If I can ping the near side of the router, then I know the cable is plugged into the router and that the router is up and running. Then I try to ping the network interface card on the far side of the router. If I am able to ping the network interface card on the near side of the router, but I cannot ping the network interface card on the far side of the router. That implies that the router is up and running, but it's not properly configured. It's not properly configured to push those packets through. Therefore, that would be a router configuration problem. However, if I can ping the far side of the router, then I know the router is up and running and it is pushing packets through. Then the next question is, can I ping some other computer which is on the same subnet as the server that the user cannot get to? So I will try to ping server 11.0.0.3. If I can ping 11.0.0.3, then I know that I do have a good cable connection to the router. If I cannot ping 11.0.0.3, then that implies that the cable is not plugged into the router. Then lastly, I try to ping server 1. If I cannot ping server 1, then that implies that server 1 is not turned on, or that the network cable is not plugged into the back, or it has a bad network interface card, or the network interface card drivers are not loaded, or TCP/IP is not properly configured. But if I can ping server 1, well, then I know the workstation's good. I know the router is good. I know the cables are good. I know server 1 is good. I know the network interface card is good. If I can ping server 1, then that means there's nothing wrong with TCP/IP. There's nothing wrong with the cards or the cables or the router. If that is so, then most likely the reason that the user cannot log on to server 1 is because he forgot his password. Ping. Troubleshooting using ping is where we employ a systematic process of elimination to determine what is good and to figure out what is bad. Now let's discuss a multimeter. A multimeter is really two tools. It is a voltmeter, which measures voltage, and it is an ohm meter, which measures resistance. Let's start out with the voltmeter first. If you are trying to determine whether or not there is any power coming out of the socket, there are a couple ways to determine whether or not there's any power coming out of the socket. This would not be a very safe method of determining whether or not there is voltage coming out of the socket. A better thing to do would be to get a voltmeter. We put one lead in one socket connector, another lead in another socket connector, and that tells us whether or not any voltage is coming out of the socket. Not only does it tell us whether or not there is any voltage, but it tells us how much voltage. If you were to plug an electric lamp into the socket, it might light up. But if this socket is only providing 80 or 90 volts, that's enough to make a lamp light up, but a computer cannot run on 80 to 90 volts. It requires the 120 volts, which is what typically comes out of a socket. So a voltmeter not only tells you whether or not the socket has any electricity, but it tells you whether or not the voltage is high enough to support a microcomputer. A voltmeter allows us to test the power coming out of the socket in the wall, and it can also be used to test whether or not there is any power coming out of the power supply. Now let's discuss an ohm meter. An ohm meter tests resistance, or you could put it another way. You could say it tests conductance. Resistance indicates that there is no connection, and conductance indicates that there is a connection. So what I want to do is I think maybe there's a cable break somewhere within this cable. Now I could just swap it out with another identical cable, or I could use an ohm meter to determine if there's a cable break within this cable. In a typical twisted pair cable, there are 8 wires, and any one of them might be broken. So what I could do is take one lead and connect it to the orange wire on this end of the cable, and take another lead and connect it to the orange wire on the other end of the cable and see if there is a cable break. If I get total resistance, what that means is that there is no connection. There's a cable break somewhere in there. However, if I get no resistance, that is to say, if I get conductance, then I know that there is no cable break. And you can use an ohm meter to to test each one of these 8 cables one at a time. Or you could use a basic cable tester. A basic cable tester is really just 8 ohm meters in one. You take one end of the cable and plug it in to one end of the cable tester, and the other end of the cable and plug it into the other end of the cable tester, and if all 8 little lights light up, then you know the cable is good. That's a basic cable tester. An advanced cable tester, such as a time domain reflectometer, can do more than simply tell you whether or not the cable is broken or isn't broken. It can tell you how far away from you the cable break is, or it can determine if there is a crimp in the cable, and it can tell you how many feet away from you the crimp in the cable is located. A time domain reflectometer sends a signal out and expects the signal to reflect, to bounce back. And based upon that reflection of the signal, the time domain reflectometer can tell us if the cable is good, and it can also tell us whether there is a crimp or a break in the cable. Now let's look at network monitor and performance monitor, which we've looked at before. Network monitor tells you how hard the server is working. It shows you how much processor time, it shows you how hard the hard disk is working, and it shows you how much free RAM there is. Network monitor tells you how much traffic is on the cabling system. It shows you overall how much traffic is on the cabling system, and it shows you how much traffic is being put on the cabling system by each individual computer. Another program used to measure the capacity or the traffic on the network cabling system is Wireshark. In this example, we can see that network utilization is 50% for a while, and then it jumps to 100%, and then it drops down to 0%. A protocol analyzer is a program which is used to capture all packets that go across the network. A protocol analyzer captures all packets. It shows the source and the destination of each packet. It shows the protocol and the contents of the packet. Good guys use protocol analyzers to try to solve networking problems. Bad guys use protocol analyzers to try to steal packets and to steal credit card numbers and to steal passwords. So if the user says, this network is really slow, you have to make the decision, is the problem that the server is overloaded, or is the problem that there's simply too much traffic on the network? So what we do is we run network monitor and performance monitor at the same time. Performance monitor tells us whether or not the server is overloaded, and network monitor shows how much traffic is on the cabling system. It shows overall traffic, and it shows how much traffic is being generated by each individual computer. As discussed earlier, part of our job in monitoring a network is to keep an eye on key variables and to determine whether or not they reach danger thresholds. And if they do reach danger thresholds, then we perform the remedial action. For example, if CPU utilization is greater than 85%, and I don't mean if it spikes to 85% for just 1 or 2 seconds, I mean if it's sitting at 85% all day long. That implies it's an overloaded CPU. So you get a faster CPU or a dual core or quad core, or move the applications to a different server. If free RAM is less than 15%, then we should either get more RAM or uninstall unnecessary applications, or move those applications to a different server which is less heavily burdened. If disk utilization is greater than 85%, that's a danger threshold. We can either get a faster hard disk, upgrade from PATA to SATA or to SCSI or maybe even SAS, or we could implement disk striping. And as you know, in disk striping, the operating system writes to 2 hard disks simultaneously, which doubles our I/O on the disk. If network utilization reaches a danger threshold, meaning greater than 50%, we can either upgrade the cabling system from 100 base T to gigabit Ethernet, or we could chop our network into a number of smaller networks, each one having fewer computers on that network, resulting in less network traffic. Now, let's turn to page 604 and discuss disaster recovery. So there are a number of actions that we can take when the computer just won't work right. So I will start out with the little ones and work up to the big ones. Let's start out with driver rollback. Let's say you've loaded the wrong driver to make things better and it just makes things worse. Well, what you can do is you can roll back the driver to the previously installed driver. What we do is we go into Device Manager. If we go into Device Manager and we right-click on our network interface card, under Properties, we can see there's an option for Rollback Device Driver. Whenever you install a new device driver, Microsoft very politely makes a backup of that device driver. So just in case it makes things worse, then we can roll back the device driver back to the original driver that we had. Page 610 discusses advanced boot options such as safe mode. You turn on the computer, you press F8, it takes you to advanced boot options. And if you go into safe mode, it will start Windows with only the core drivers and services. So here's an example of when you would use safe mode. Let's say you have loaded the wrong device driver. And loading the wrong device driver prevents the system from booting at all. So if it prevents the system from booting, then how could you possibly implement driver rollback? Well, the way you do that is you boot to safe mode. You boot to safe mode, you press F8, the system boots, but it doesn't load that problematic driver. Then you go to Device Manager and you uninstall or roll back the device driver. If you have loaded the wrong device driver and it prevents the system from booting normally, you go into Advanced Boot Options and select Safe Mode. Notice it says Safe Mode in each corner of the screen, and it gives us a description that this special diagnostic mode of Windows enables you to fix a problem which may be caused with your network or hardware settings. So I go into Safe Mode and I go into Device Manager, and then I can roll back that device driver that prevented me from booting normally. Safe Mode is used when you have loaded the wrong driver, and that wrong driver prevents the system from booting normally. So you go into Safe Mode, go into Device Manager, and uninstall or roll back the device driver. Now let's discuss System Restore, page 607. Whereas driver rollback allows you to roll back a particular driver, System Restore rolls back all drivers. It rolls back all system changes that you have made. So let's say I started working on a computer at 9 o'clock in the morning, and I changed the computer name, and I changed the IP addresses, and I unloaded some drivers, and I loaded some drivers, and I made a lot of system changes, and by the time it was 4 o'clock in the afternoon, I made such a mess of it that I wished I could just roll it all back to the way it was at 9 o'clock this morning. And that's what System Restore does. It's like driver rollback, but it rolls back all changes that you have made. If we go into System Restore, we can see that System Restore does not affect any of your documents or picture files. It only restores configuration variables. It's like driver rollback, but driver rollback only rolls back one driver at a time. System Restore rolls back all drivers. It rolls back all system changes which you have made. Now let's discuss last known good in the registry, page 607. As you know, the registry is a configuration file. And in the registry, all configuration parameters are stored, such as computer name and IP address and DNS suffix. All configuration parameters are stored in the registry. If you look at Advanced Boot Options, there's an option under here that says Enable Last Known Good configuration. Now, if we look at the registry, we will see there's something called current control set, which stores all the current configuration parameters, but there is another folder here that says last known good recovery. Every time you log into the computer, the registry makes a backup of itself, and it saves the backup in what's called last known good recovery. So when you want to roll back the registry, you boot into advanced safe, you go to advanced boot options, and you select last known good configuration. And what that does is it restores the last backup that was made of the registry. Now let's discuss system recovery and repair, page 606. Windows RE stands for the Windows Recovery Environment. So what you do is you can boot to the DVD to run Windows RE, and it has a number of disk repair utilities, and one of those utilities is called Startup Repair. The reason that you would use Windows RE, the recovery environment, is because you can't boot normally, you can't boot to safe mode, you can't boot at all. So maybe it's a corrupted disk drive. So what you do is you boot to Windows RE, you boot to the DVD. And when you do, you have a number of system recovery options. Now, we've already discussed what System Restore does. Let's look at Startup Repair. When we run Startup Repair, what it does is automatically fix problems that are preventing Windows from starting. In other words, it rewrites the key boot files to the hard disk. The reason we're using System Recovery is because we can't boot normally and we can't boot to safe mode. So in disaster recovery, I have it listed from not so bad to bad. If you've loaded the wrong driver, you just go to driver rollback. But if it prevents it from normally booting, then you would use safe mode. So then you could implement driver rollback. System Restore is like driver rollback, but it allows you to roll back all configuration variables. Last known good allows you to implement a backup of the registry. Windows Recovery Console is where you boot from a DVD and you can run repair utilities that can fix a corrupted disk. Now, if that doesn't do it, if Startup and Repair doesn't do it, well, then the next thing you would do is you would wipe the disk and reinstall the operating system and then restore from a backup. And if that didn't do it, you would purchase a new hard disk and then reinstall the operating system and then perform a restore from backup. Chapter 13, Summary. In this section, we discussed documentation, the troubleshooting method, web resources, troubleshooting tools, and disaster recovery. This concludes Chapter 13. Thank you very much, and have a nice day.